Alright, let's start talking about the Arduino command line interface. And to start talking about that, I think it's useful to remind you from the previous videos about the life of an Arduino sketch. So what you're in charge of doing is creating an INO file. So you create the INO file and you write your code in it. And then next you can, let's say optionally, include, let's call those custom header and source files. After that, you can optionally include official or third-party libraries. After that, you will build, which we can also call compile, you can compile the sketch and then upload the sketch. Sometimes you'll hear me call that flash the sketch. And then finally the board resets. Let's say jumps to your code. Or let's say the sketch. Let's see, did I spell that wrong? No, I'll just add that word. So that would be the life of an Arduino sketch. So you are in charge of this first step. Sometimes you'll have additional header and source files that you want to include. A lot of times you'll just use third-party libraries. And then you compile and flash the sketch. We're going to look at doing all of these steps using the Arduino command line interface now instead of using the Arduino IDE. This will solve some problems for us as computer scientists since we're a little more comfortable writing code and compiling code compared to the general population, which is what the Arduino IDE is built for. It's built for people, the terminology is built for people, the buttons and the processes are built for people who are just less comfortable with this technology. But we will start by me going into the root. Actually, since I'm in this directory, I might as well delete the temporary files. So we'll start by checking to see if I have installed the Arduino CLI. And if I run the command, I don't get an error, so I know that I've installed it. If you're on a Mac machine, you can use Homebrew to install it. The website, which I'll link in the chapter, will give you alternative options for installing it. So my assumption here is that you follow the correct instructions for your computer and have it installed. The next thing to try is to check to see if your board, if the correct boards are installed. So I'll do a list all of all boards, and you can see my Arduino, my laptop is actually set up to compile sketches for a lot of different boards. So I can filter that output by the board that we're actually using in this class, which is called the Xiao ESP32S3. I'll just put Xiao in there. And you can see there are a few boards that are already installed on my machine, one of which is the board that we need, the Xiao ESP32S3. So this is the same thing you would find in the Arduino IDE when looking, searching through the boards. This is called the FQBN, the Fully Qualified Board Name. And if you recall from the previous videos, I said the init functions and functions like analog read, analog write, the serial communication interface, those are all defined in other files depending on the architecture that you're using. And the fully qualified board name is what's used to figure out which files you actually want to include. So analog write is defined specifically for this chip, for this manufacturer, and that functionality gets included into your sketch whenever you compile it. This is what Arduino is really good at, is making it so that you can easily switch from one type of architecture to another without having to change much of your code. You can still just call analog read, analog write, and assume that that is going to behave similarly across architectures. The Arduino CLI will use the same libraries and same boards installed through the IDE. So if you installed the ESP32 by Espressif Systems through the IDE, you should have them available here. If not, you can install them by running this command, which I won't do here since I already have it installed on my laptop. Alright, let's start creating a new Arduino sketch. And I'm going to create one to work with our compass. So I'm going to go into exercises and create a new file in here called compass. We're not going to, in this video, get through the entire exercise of using the compass. That'll be what we do next week in the next chapters. Instead, I'll just show you how to get all of that set up and functioning so that you can compile and upload scripts or sketches to your board. So when I say sketch new compass, it'll create a new directory inside my current directory called compass. So you can see I have display, OTA, and now compass. And inside compass, it creates the INO file, the sketch file. And if I open that, it has pre-populated it with the two functions that we need for our program to run, or to compile. In fact, I'll make a change here just to show what happens if we don't have one of those defined properly. I'm just going to leave those blank for now. And now we'll go through the process of actually compiling that sketch. So the command we want to run is the compile command. We need to tell it what board we're compiling for. If it doesn't know what board, it doesn't know what files to include. So I'm going to run compile for our board. And this is a process that takes a little bit of time, so I'll hit enter. And of course I have to tell it what to compile. I'll hit, and I spelled it wrong. I'll hit enter, and then I'll pause the recording here so you don't have to wait for this to compile. Actually, that was fairly quick, just because I'm not including any libraries. It only took 5 seconds. And actually, it errored out because it couldn't find the loop function, which it was expecting to find. Trying to see if there's any. So if we look at this one line at a time, undefined reference to Z4 loop V, Z8 loop task PV, Z4 loop V. Yeah, so the error message here leaves a lot to be desired, but essentially what it's saying is you're missing the loop function. C++ performs something called name mangling, and that has to do with what I was mentioning in the previous video, with different functions having different arguments, but C++ being able to figure out how to call them. It does this through a process called name mangling. Obviously in code it can't call them both loop, so it'll mangle the names so that the name doesn't just include the ASCII characters of the name, but it also includes what the arguments are. So that's what that like Z4 or Z8 are all about. But now if I try to compile this again with the correctly named loop function, I had to wait 11 seconds to have this compile. And we get the same output that you would expect to see in the Arduino IDE. It tells us how many bytes our program took up, and it gives us a little bit of information about the executable that we compiled. So you might notice there's nothing new here inside exercises. And if I go inside compass, there's also nothing new in here. No hidden files as well. This is one thing that annoys me right off the bat. I'm used to having control over the build files, so the actual executable that gets created. And I like seeing it there because I like knowing when it's changed, because I like to use makefiles for compiling files. And it's really hard to do that when Arduino is putting these in hard-to-find places. In fact, if I rerun this command to compile, I believe we can get it to tell us exactly where it's saving that file. And by file, I mean the actual binary that gets output. And you can see it's storing a lot of data inside private var folders. This is a temporary directory on a Mac. On Linux, it would be in a different temp folder. On Windows, it would be a different temp folder. The point is, the Arduino CLI is putting it somewhere that it can find it, that we're not really meant to find it. So that's the first change I'm going to make, is I'm going to suggest, since we're going to eventually head toward makefiles, I'm going to suggest that we tell the Arduino CLI that we actually do want to know where those files exist. And you do that with the export binaries flag. When you say export binaries, it'll put the compiled files, the artifacts, inside the sketch folder. So this finished compiling. And now there's a build folder inside the compass folder. Inside build, you'll see that it creates a subfolder for this specific architecture, which is nice because I might want to build this same compass INO for multiple architectures. And then inside that file, you'll find the actual binary that we would want to upload to the microcontroller. So that's one small improvement, is adding this exports binary flag. Another small improvement would be to make it so that we don't always have to specify the fully qualified board name. It's not going to matter much if we put this into a makefile, but it will require less typing for other commands too if we create what's called a configuration file, a project configuration file, where this is automatically specified for us. And so one way to do that is to add the dump profile command, or sorry, the dump profile flag to this command. And after it's done compiling, you'll see it spit out a profile that would mean we would no longer have to specify the fully qualified board name. I could just copy and paste this into a file, or I could redirect it into a file. But instead of doing either of those, I actually added a few other additional pieces to the project file. So instead, I'm just going to copy that over and explain what those changes I made were. So inside the compass directory, I'm going to create a new file called sketch.yaml. So this is a default name that the Arduino CLI will try to pick up and use. And here's the contents that I'll put in there. I can put a default FQB in, and so that'll be used for all profiles. A default protocol, so how am I going to flash the microcontroller? And I'll also say what the default profile is. So for this one, I could call this anything I wanted to. But I thought the value that was spit out on the command line made enough sense that I just left the name. So for this profile, I can say what the platform is. So we're going to be compiling using the ESP32 platform. You can also add libraries. And this is the one place where Arduino is making some good changes to the Arduino CLI that you can't even do inside the Arduino IDE as far as I'm aware. You can specify the exact version of the library, which is nice. So that makes it easier if you have a project that uses the version 1 of the U8G2 and you don't want to break that older version. You can specify that newer projects might use a newer version of the library, for example. You can see I was playing around with and demoing this code with the display exercise. So here we don't actually need any libraries yet. We'll populate that later when I tell you which library we're using for the compass, the magnetic compass. So for now, this should mean that we can eliminate a little bit of the code that we had to write for compile. So I should be able to say Arduino CLI compile, and I want it to compile compass, and I want it to still export binaries. And that's just eliminated some of what I would have to type at the command line. And with about 11 seconds of time, it was now able to compile that without me having to specify the fully qualified board name manually. Annoyingly, I do need to specify export binaries. That's not something, as far as I can tell, you can put into the sketch configuration file. On the other hand, I can put that in a different configuration file. So not in the compass sketch YAML file, but in a more broad configuration file that I can tell the compile command to pick up. So I'll create a file in the root of our code directory called arduino.yaml. And inside that, I'll say for sketches, I want to use the always export binaries. I want to use that flag every time I compile. So now, in the end, I can say compile compass and pass in a config file, and instead of passing in the export binaries flag, I'll just pass in the config file flag, and export binaries will be specified inside this YAML file. This is slightly advantageous, even though I still have a flag here, because I might eventually have additional configuration options that I want to put inside this project file. Sorry, this configuration file. The sketch YAML is the project configuration, and this is the more global configuration. Those are two separate configuration options. Something that I didn't try, and maybe I'll try before we meet in class, is I never actually tried to put that configuration option inside here. But again, I'll keep moving forward and not worry about trying that right now. Alright, well, now that I have compiled sketches, so the sketch inside compass, the next step would be to upload that to the microcontroller. And a good place to start would be to just list all of the boards that are attached to the computer, that are connected to the computer. So that's not list all, that's just the list command. And currently, the Arduino CLI program is only picking up one port that it thinks is a possibility. This is actually not what I want to use, and that's because I haven't actually plugged in my microcontroller yet. So if I plug in the USB cable and rerun that command, I should have a new value pop up. And indeed here, I've got the dev cu USB modem 2101. It even can identify it as an ESP32 device. It doesn't know the fully qualified board name. It doesn't know that it's a Xiao ESP32S3, so we'll still have to specify that, but it does pick up some information about the device itself. So if we want to upload a sketch, I could do Arduino CLI, upload, and you can see I could pass in a lot of information here. I could pass in the fully qualified board name, and I can also pass in the port. And then of course I also need to pass in what do I want to actually upload, and the way to do that would be to just give the directory name with your sketch in it. And if you just give the directory name, it's going to look in that temporary file location, so that /private/var directory. So instead, what I'd like us to use is the input file option, or the input directory option. I found the input directory option a little bit easier to use just because I don't have to remember which of the binary files inside the build directory I have to specify. The Arduino CLI is smart enough to figure out which one is the correct file to upload. But if you're curious, it is in fact the compass.ino.bin that I'd want to upload. So I can list this as input file. And so you'll get if this is working correctly and your board is willing to accept the program, you'll get that familiar output where it tells you how much of it has been completed. And then at the end, it will reset the board so that it starts running your new sketch. But there's a lot of extras on this command line that I don't actually need to specify because I've put them inside of this sketch.yaml project file. So the fully qualified board name I don't need to put in there. So I can remove that from my call. And I could have something a little simpler like so. I can also leave off the port and just give the directory in which to find the binary. But here it's saying I'm missing the FQBN, which it should pick up from the sketch YAML file. What am I missing here? Let's see, let's grab the profile out. This was not a problem I ran into when I was putting together my script for this video, so I'm going to take a few seconds here and figure out what I'm doing wrong compared to when I was doing this for the display example. And I think I realized the two things I missed. I forgot to give it the actual name of the directory to upload. You have to do that in addition to the input dir. And I realized I never actually set the default port here. And so what port have I been using? Okay, so this should be enough to upload. And out of curiosity, do I need both of these? For some reason I didn't think I did. I do need that, because that's where it gets the... you have to tell it the name of the directory in which the INO is found so that it knows how to pick up the sketch.yaml file. Alright, so those are the main pieces that are necessary. I have to tell it where to find the configuration file, and then I still have to tell it I want to upload from here instead of going off and finding it in that private var directory. I should also mention it's possible for the port to change, especially if you have multiple devices plugged into your computer at the same time. On my MacBook, it's been pretty stable, almost always USB modem 2101, but do keep an eye out for that if you see some errors talking about not being able to find the port. Alright, that's a good place to end this video. In the next one, I'll show you how to make it really easy to use those two commands, the Arduino CLI compile command and the Arduino CLI upload command, so that you don't have to type them out every time. Instead, we'll be using a makefile so that we have to sort of remember less each time.